A very warm good afternoon to all of you. I'm Sakshi, welcoming you all on behalf of Solar Quarter and First View Group at today's thought provoking webinar on how intelligent PV cleaning robots are shaping solar maintenance in the Middle East. I would like to express my gratitude to our partner Sunpure and to our panelists for extending their immense support to organize this event. As we are aware, the Middle East solar upkeep is being significantly shaped by intelligent PV cleaning robots. The PV panels are employed in the solar energy industry, and these robots are made for cleaning them. The Middle East is notorious for its hot and dusty environment, which can cause dust and other debris to build up on solar panels. The quantity of energy generated might the quantity of energy generated might ultimately be decreased due to this buildup, decreasing the solar panel's efficiency. So, in this exclusive webinar today, we will talk about the difficulties with maintaining solar panels in the Middle East and the importance of intelligent PV cleaning. May I introduce Mr. David, Chief Technical Officer from Sunpure, to give the presentation for his company. Over to you, Mr. David.
Okay, thank you, Sakshi, and thank you, Solar Quarter, to give us this opportunity for the presentation. Just give me a second. Let me share my screen. May I ask, can you see my screen, Sakshi?
Yes, sir, it's visible.
Okay, good. So for the next about 15 to 20 minutes, I will talk about automated robotic cleaning, the challenge. I'm David Zhang, Chief Technology Officer of Sunpure. As you may know, Sunpure is dedicating in providing the ARCS solutions for this industry. My presentation will be divided into three parts. So first part is about the importance of dry module cleaning solution. Second part is challenges and learnings from the past experiences. And third part is, first, I just want to spend a little bit of time to discuss why do we need ARCS. So here are two interesting pictures in this slide. The left one is the global solar irradiation map, and the right one is the global soiling zone map. And very interestingly, there's a big overlap between high irradiation and high soiling zones areas. These areas including like Middle East, India, North Africa, South America, and part of Australia. So it means where there's a need of developing the solar plants, there might be a need for frequent module cleaning to ensure the cleaning efficiency. According to some researchers, the worldwide average annual soiling loss is 3% to 4% globally, and resulting in about 3 to 4 billion euros loss per year. And for MENA region, so this annual soiling loss is much higher than the average. It can be as high as 35%, which is shown in this map. If you see this map, there's about 35.59%, and which is located in the MENA region. So it is easy to imagine, if not properly cleaned, how much the economic impact the soiling loss may have. And then another question is, how frequent does the cleaning is required? We have actually studied the soiling conditions from various sites and found that typically the average soiling rate per day is around 0.3 to 0.5%. So which means each day the soiling loss may increase by 0.3% if not clean. So considering all the above factors, we believe that the cleaning frequency of 1 or 2 days is necessary in Middle East. And for such frequency, only with ARCS it is possible to achieve. And in these slides, I want to show some other interesting photos. And these photos comes from a soiling loss test in Middle East. And each photo shows some typical soiling loss values corresponding to the different dust conditions on the module. And by comparing these photos with what we usually see in the site, you may find that for a typical solar plant, if modules are not cleaned like once a week, the module condition will be most likely similar to the pictures in the first line, which may be about 10% to 23%. And if your module is not clean for 1 month, the conditions of the modules will be most likely similar to the three pictures on the bottom, which may be between 32% to about 50%. This is also, similar to what is shown in this figure, which is about 35%. Okay, so I guess all the participants here are familiar with, with this area. So I just spent a very small time to introduce the importance of the, ARCS in this region. So next, I want to, spend some time to discuss about the challenges for this robotic cleaning industry and also the learnings based on our, previous experience. As you know, hello, I think I hear some background noise. Is anybody? Okay. So, okay, let me continue. I think many people know that ARCS was developed about 10 years ago, and the massive installation of ARCS into the PV plant started from 4 to 5 years ago. And during these past few years, this industry developed very fast. And I believe the technology of ARCS is getting more and more matured. We at Sampure understand well, what a good technology should be and how to fulfill the requirement from a solar side perspective. However, I think what we found that the shortage here is, or what need to be improved, is the understanding of ARCS technology from other related parties, because this is not an independent technology. This technology needs to be integrated into plant and has a lot of interaction with trackers, with modules, and with plant SCADA and some other stuff. So we not only need to look into the impact of ARCS on the other systems, but also need to look into the impact of other factors on the performance of ARCS. Actually, I think this is what we need to improve in this industry. And this is also, what we learned from the past experience. Take tracker as an example, because the robot is running on top of trackers, and there's a lot of interaction between them. So many of the tracker factors have impact on the performance of ARCS. Here, I just listed a few factors that has big impact on the ARCS. One, for example, the first one, the tracker communication grouping. This is not easy, not difficult to understand, because one robot is passing through like 1.5 kilometer length in a row, and it is passing through the different communication zones of the tracker. And between different communication zones, the synchronization usually is not really good, so it will cause the angular difference between adjacent communication groups. As shown in this right picture, you can see the very high angle difference between different trackers. And this, to be honest, is very common to happen, and also can show in this picture. This is a real side picture. And how to deal with this tracker angular difference is a question for ARCS suppliers. and it's also a question for the trackers. So that's the first factor that I want to highlight. The second factor, the trackers control accuracy. This is also related to the angular difference of the tracker rolls, because say if the tracker's cleaning angle is 30 degree, but if the actual angle is 35 degree, you can imagine how different it is between the design one and actual one. And this will also cause or reduce the performance of the trackers. And the third one is the tracker types. So here we, in the market, we have 1P, 2P, and we also have a single point drive, multi-point drive, and exchanger. And this will all have impact on the robot, because say if you have only single point drive, then the rotational restriction is in the center of the tracker. And then in the end, the control or the restraint of rotation by the tracker is less or is worse. Of course, it will have the impact on the possibility of the robot in the end of the tracker. And the fourth one I want to highlight is the tracker's wind stall strategy. Both trackers and robot need to be stalled at high wind. So both of us has the independent wind stall strategy, but these two suppliers need to coordinate with each other so that the wind stall strategy is compatible between tracker and robot. We will need the robot to go to stall stage before the tracker wind stall happened, so that the situation that both tracker and robot is moving at the same time will not happen. If it happens, you'll have a lot of system risks and will impact. And the fifth one is the tracker's communication protocol. Nowadays, I think in the market, there are mainly two different wireless communication protocol for trackers, which are ZigBee and LoRa or LoRaWAN. And for robot, most of them using LoRa or LoRaWAN communication protocol. So if both trackers and the robot using the same LoRa communication, we need to ensure that the interference between trackers and robots will not happen. So this is also another very important factor. And the sixth one is a module reel design and the stiffness. Recently, I have seen there's a trend that the tracker company is reducing the thickness of the reel to save the cost. However, before the decision can be made, we must check that whether the reduced thickness of the reel can support the weight of the robot. So this will be a separate factor to check before the decision can be made. So this slide, I will show the factors from the site or from the site situation. You can see there are a lot of actual situations in the site that may have the impact on the robot performance. For example, first, the slope. So the undulation, I understand it cannot be avoided in the site, and also EPC do not want to do a lot of cut and fills to make the site very flat, because there's a lot of cost impact. But before we can make the decision about what level of cut and fill should be made, we also need to check whether the robot is able to operate or perform well under this site situation. If not, I think a certain level of cut and fill work or earthwork need to be done. And on the right, these are a few photos to show some not really good construction quality. You can see some, a big vertical offset and also horizontal offset between adjacent trackers. And this all will impact the capability of the robot to pass through these different trackers. So normally, during the detailed engineering stage, or even before that stage, agreement need to be made between EPC and the tracker suppliers and the robot suppliers about the construction accuracy or construction tolerance. Only within the agreed construction tolerances, the ARCS is able to perform smoothly and run smoothly. This slide shows another factor, which is a layout. Here I show 3 typical layouts, from the actual site in the Middle East. Regarding to the layout, we also have a few suggestions or recommendations which may affect the overall solution of the ARCS. The first one is the maximum row length cannot be too long. Recently, I've seen in one project, the maximum length that each robot can cover is about 3 kilometers. So if you do the return run, then that means each day the one robot need to cover or need to run about 6 kilometers. And for a typical robot, it takes about 6 to 7 hours. So this is really not good because as you know, the cleaning window of each day is limited. So if each robot need to run very long time or very long duration in one day, it may miss the cleaning window because say if in the winter, if dew forms in the midnight, the robot is not able to go back, then this dew will have impact on the cleaning performance. And the second suggestion is the tracker-to-tracker gap in north-south direction cannot be too short. We need to maintain a certain distance between adjacent rows so that to accommodate the tracker angle difference and for the robot to move smoothly. And the third suggestion is purely on the economic perspective. So if possible, we need to use as many long rows as possible, but of course the long rows should be limited. The maximum length of the rows cannot be too long as pointed in the first point. But of course, for this third layout, if all the rows are long rows, then of course for the same capacity, the less number of the robot has to be employed, and then the system cost will be reduced. And this slide, I want to show the importance of communication. Communication is, another important factor in this solar plant because at the site, ARCS need to communicate with tracker and weather station through plant SCADA. So a very good communication system is very essential to ensure the good integration of ARCS into the PV plant because the ARCS need to understand the tracker's angle information and also need to understand whether there are any harsh weather happens. So if the communication is too slow or unreliable, it may put both trackers and robots at a dangerous position if there's any extreme weather happens. So the communication, what I mentioned here is not only the communication for the robot itself, but also include the communication between the robot and the tracker, and also between the robot and the plant SCADA. It's only when all the communication direction is integrated well, the whole system is under stable conditions. Okay, then comes to the third part. I want to spend a little bit of time to introduce my company and also introduce our solution to address the previous concerns and the challenges. Sunpure is the first EcoChain company of Sungrow. So we were born from Sungrow's lab, and we were established in 2019. And although we only have 4 years experience, we have gained a lot of achievement, including we have deployed our projects in more than 12 countries globally, and also more than 7.6 gigawatts of projects either awarded or has been delivered. And we are technology-oriented company, so you can see the figure, about 70% of our staff are technical personnel. And we also get a lot of awards, both in China and in the Middle East. And our target is to become the leading player in intelligent cleaning market. In this slide, I just want to show some of our technical highlights. As I mentioned just now, this ARCS is a solution. This solution not only includes the robot, but also has the communication system, has a steel structure, and has a SCADA and Accenture. So to be a good ARCS solution provider, you need to be good for all the aspects, not only like the robot itself. So I just highlight a few of our highlights. One is at the level of cloud, we have introduced an IoT-based platform and using Sampure's own databases. So for each project we have deployed, it is able to communicate with both end terminals, which are our robots, and also the external resources like the trackers, weather stations, and PV SCADA and Accenture. And of course, we do not only rely on the cloud and the communication, because we understand that even the most advanced wireless communication technology cannot ensure no data loss, especially at a gigawatt-sized project. So considering above, at the robot level, we also introduced the smart control algorithm. For example, we have the self-adjustment feature. And when the robot runs off the track, it will automatically adjust the posture and get back to the normal routes. And also besides, at the robot level, there's also a self-learning ability and risk mitigation algorithm, which I will introduce in the next slide. So this is to ensure that when this network loss due to whatever reason, the robot has the self-protection function to avoid the risk of damaging the overall PV system. And another highlight of our product is, as shown in this animation, we have a dedicated wind protection system, which provide a hard lock to the docking station while it's parked. So it ensures that the robot is not only able to resist low to medium wind or everyday wind speed, but it also able to resist extreme design wind speed, which may happen like once a year or even once a few years. And lastly, I want to highlight that we provided a customized solution for different projects. And the solution include, as I mentioned, the robot, the engineering structure, the communication system, the SCADA, or the Sampure Cloud. And the commissioning and after-sales service, of course, is included. We also have provided our robot with various lenses, and the lenses comes from 1.6 meter until 30 meter long. So even your project has irregular layout, we still have the solution to to meet the requirement. So here's the last page. I want to just stress on the risk mitigation because this would be very important for a large project. The risk mitigation is addressed through two aspects. First is through our communication system, which is very important aspect of our solution, as I mentioned just now. So with the fast and reliable communication, we can ensure the robot being able to respond very quickly to reduce the operation risk and the extreme weather station. And here is actually a video. Oh, sorry. This video actually shows how the robot reacts within 1 second after the command is issued. Yeah, but of course we understand we cannot solely rely on the communication system because the communication may lost even it's very reliable. We cannot ensure 100% of the communication connection. So we also develop our system to have the local detection and decision level at the robot level. So this includes the detection and auto protection after the communication disconnection, and the detection of disengaged bridge and protection of robot from falling off, and also include the detection of abnormal conditions along the travel path and its auto protection. So here is the brief introduction about Sampure's technology, and I'm sure this limited time cannot cover everything about this system and about our technology. So I think if anybody has some interest, you can contact me or other for my colleagues via any methods. That's all about my presentation. Thank you very much.
Thank you so much, Mr. Zhang, for that insightful presentation. Here, I would like to make a small announcement. Attendees can post their questions in the Q&A box, and our speakers will take up those at the end of the panel discussion. Now, without any further delay, let us initiate our much-awaited panel discussion session for today. Allow me to introduce the proficient panel. Mr. Samir, who will be our moderator, and he's a carbon market national expert. Mr. David from Sunpure Technology, Mr. Ahmed Meher from Taka Arabia Power Group, Mr. Ketan Patel from Sterling and Wilson Solar, Mr. Omer from Nomad, Mr. Ahem from EDF Renewables. Over to you, Mr. Samir.
Thank you very much, Shaksi, for this fantastic introduction. Big thanks to our sponsors, SunPower, and all the Solar Quarter staff behind the scenes that are doing fantastic job. We will start this dialogue with Mr. Ahmed Maher, who is the solar O&M manager at Taka Arabia Power Group. Mr. Maher is the head of the O&M, and he has a master's in solar energy with practical experience with more than 13 years. They have over 100 megawatts of solar, and the scope of Taka Arabia is making O&M to their own projects right now, and they are the biggest Egyptian solar developer in 2022. Mr. Ahmed, are you with us? Mr. Ahmed? Oh, Mr. Ahmed is. Can you check Shaksi and Avanti if Mr. Ahmed is around?
Yes, he seems to have dropped out due to some internet issues. We'll just check with him.
Okay. Do we wait on him, or do we move on to our next speaker? What do you think?
I think we must move on to our next speaker first.
Okay. Mr. Ayham, are you with us?
Yes. Hi. Good afternoon, Samir.
Okay. Good to see you.
Yeah, likewise.
Let me do a quick introduction of your good self. Mr. Ayham has over 16 years of experience as a solar professional in utility scale projects and distributed solar projects. He is holding senior roles across solar value chain, covering 11 countries in MENA and Europe. and touching over 2 gigawatt of solar projects in various capacities. He's the operation director for EDF Renewables, overseeing operations of 1 gigawatt DEWA 3 PV plant in Dubai. And he's leading the digitization transformation within the group and supporting it in bids. You have plenty of jobs on your plate, and this is really we are very lucky to have you among us today.
Thank you for having me.
Brilliant. We would like to start with asking you about the important factors to consider when deploying robotic cleaning products. Over to you.
Well, thank you, Samer, and thank you, David, and panelists. It's an honor to be here alongside a very capable group. So I think there's quite a bit of important factors to consider when looking at robotic cleaning solutions. David, in his presentation, touched on many of them. So I think one of the things that we have to bear in mind is when we look at cleaning solutions is kind of what we model versus what we actually achieve in reality. And some of the very important factors to consider is, how do we ensure that what we modeled can be achieved in reality? And some of the factors are really dependent on looking at vetting a lot of the robotic cleaning manufacturers to ensure the cleaning efficiency. I think that's one critical part. And by cleaning efficiency, I mean when you do clean rows of solar panels, how efficient it is at clearing off the dust and how effective it is at doing so. So that's quite important. I think another factor would be adaptability. David touched on that quite a bit. When we look at kind of designing a plant, we need to consider the integration of the tracker solution with the robot and the SCADA. So many things. So adapting our design decisions are quite important to ensure that the robotic cleaning solution matches with that design. So I think those would be kind of quite important. There's obviously safety features which become very critical. David touched on those. Remote monitoring and integration to the SCADA system, maintenance and support for the long time life of the cleaning robotic solution. We want to make sure that rigorous maintenance activities are performed on the cleaning robots and the equipment surrounding it, such as the bridges that can link trackers between each other, just to ensure that there is no downtime or long durations where the robot's not operating. So I think those would be kind of the most important factors, in addition to one which is vendor reputation. Robotic cleaning manufacturers, they're increasing in number, and we just need to make sure that the solution that we kind of adopt is bankable and will last the lifetime of the plant, of course, with a lot of maintenance going on. So that in my opinion, are some of the key factors to consider.
Very, very nice. How about the expected lifetime of the robotic equipment, and how many years of maintenance do you ask for your supplier to abide by?
So yeah, it's an interesting question. As you know, a lot of these technologies have existed for under a decade in scale, let's say. So it's always an interesting question to look at. I think what we always want to see is that there's the availability of the spare parts to repair the robotic cleaning solutions. These are running on a daily basis, and there's going to be a need to ensure that we replace the parts and consumables within them, following the maintenance recommendations as well. I believe that these solutions should probably last the lifetime of the plant, but with major overhauling needed over time. So there's going to need to be some investment and budgets to ensure that we continuously repair and maintain the cleaning solutions.
Very interesting. Uh, how are the modeling of soiling losses and translating into robotic cleaning requirements? How do you do the modeling of the losses?
Yeah, so I think that really comes down to the design decisions and kind of the land that's available, the location, how often how as David's graph showed, in many parts of the world, for example, in the Middle East, especially in the GCC countries, you have quite a lot of soiling. It could amount to 0.3 to 0.5% per day, depending on the location. So those factors are quite important to know at the start, so that when we come to design a robotic cleaning solution that matches with the plant, we know the frequency that we want to clean the plant to achieve those losses. And then back to kind of what I was saying earlier, learning about the cleaning efficiency of the robots. So one of the things we do as a group is we vet the cleaning robotic solutions in our headquarters, and we kind of test and play around with the different variabilities and what the cleaning efficiencies can be. We're also looking at building a test field here in the region, so that we can adopt the cleaning solutions and we can see how they operate against each other, and to determine what those cleaning efficiencies are, so that when we come to model our assumptions, they translate into reality.
That's very, very smart, actually, if you want to build your own testing facility and bring different robotic cleanings from different vendors and see the actual performance. This is very smart. A little bit expensive in amount of time and money, but this is very smart. Maybe we ask you one more question, if you allow us, about the design decisions that enable efficient and cost-effective robotic cleaning solutions. What are your key decisions for efficiency?
Yeah, so the way I look at it is that we want to try to make tracker rows as long as possible, as was discussed in the presentation, because with that, what we can do is with long tracker rows and bridges, we can sweep clean with one robot a longer row. Sometimes looking at two in portrait versus one portrait. If we have two portrait configuration, it depends on the area, the land, and everything, and the design. There we can, with one robot, kind of use that to sweep more kind of linear meters or more peak power kind of as we sweep through. So that's important. The bridge solutions are quite important to look at and see, because with the trackers being misaligned for many reasons, and that's very possible. We want to make sure that that they don't dislodge, or they stay intact, and that the robot is freely able to go down and sweep the longest row possible. So these days we're looking at kilometers of row, kind of linear row that can be swept clean with robots, whereas in the old days it was a lot shorter. So that can definitely drive the costs down.
Very interesting. Yes, if you're lucky enough to have a very long land, you can you can deploy
Exactly.
one robot, and but depends on the land. Let me ask you, how many times do you clean every day, or sorry, every week, and which part of the day are you cleaning? Is it at night, early in the morning, late at night? Over to you.
Yeah, so I think it depends on the plant and the design, but typically, we do. There's anything from cleaning once every day, and that's if we modeled the soiling losses to be, around the 0.5 or 0.7 or 0.3%, depending on the area. And then in other cases, there's plants that were older where the cleaning robotic design was different. So we're cleaning like roughly once every 6 to 8 days. But I think beyond cleaning once a week, it becomes a bit of a challenge where if we don't clean frequently, then the dust and the humidity in many parts of this region cakes on the dust and it becomes very hard to remove. So frequent cleaning is very important to ensure that that layer that's depositing is continuously removed, and so it doesn't cake on when yeah, with the sun coming up after humid days. And in terms of cleaning, we believe, kind of in the evenings, just after sunset, is ideal for cleaning. If there's no humidity, humidity is an important factor to consider. We do not clean if on humid days, or we wait until the humidity drops, because otherwise the cleaning actually becomes an opposite problem. It actually soils the modules more. So it's definitely a lot of factors to consider, and I think the future of robotic cleaning will evolve to include all of these parameters inside to make informed decisions about when the best time to clean is.
Oh, I just want to ask one more question. Are you doing wet cleaning or dry cleaning? Because you touched on you focused on the humidity factor as very important. Over to you.
Yeah, we typically only do dry cleaning. I think we're firm believers of being sustainable in solar power projects. So I like to say we don't want to irrigate the desert in our conditions, and we want to keep it sustainable. So we found dry cleaning to be quite effective. Wet cleaning is usually done mostly on a spot basis, so and stubborn stains or bird droppings, etc. But we typically do not do any wet cleaning.
Very interesting. And so, but is the dry cleaning causing any surface itching of the PV modules, or are you ordering special modules for your plants, or is it how are you approaching the scratches from the dry cleaning?
Yeah, I think that's a very important factor. And actually, what we do is we make sure with the module manufacturer and the robotic cleaning manufacturer that we test before deploying the robotic cleaning solution. We test it on the modules, and we get approval from the module manufacturer that it doesn't void any warranties, or it doesn't, deter the production. What we do on an annual basis is we test the sample module in laboratories to make sure that the degradation is in line with the requirements. And so far, we have not witnessed anything out of the ordinary.
Okay, so you're testing at international labs, not in your labs,
Yeah.
and and you're testing for the duration, like the life cycle of if you have 30 years and 365 days, and so that's close to, let's say, 10,000 cycles of robotic movement over the PV module, or am I close? Over to you.
Yeah, it depends. So yeah, it's either once per day, depending on the plant, or kind of once every week. But yeah, it's the brush material is quite important to consider. Some brushes are more abrasive than others, so it's really important to do kind of trials with the robotic cleaning manufacturer and to see what it does to the coatings on the module, and to ensure that coating is going to be eroded over time. This is a fact that we have to live with. It's just how much it affects the performance, and to do accelerated testings in third-party labs to kind of verify that. So we've done on many of our projects kind of accelerated tests.
Okay, and I hope that you have SunPure products, robotic products in your test facilities, and you will use them a lot in the future. Okay.
Not yet, but yeah, we're open to exploring all
Wow.
different manufacturers, and SunPures, we know them quite well, so I think we'll look forward to that.
I'm sure that David will do the needful. Thank you very much, Iham, and I'm sure that we will come back to you with more questions from the audience in the Q&A session. Thank you very much.
Thank you so much.
Mr. Patel, are you with us? Can you hear us? Mr. Patel?
Yeah, good afternoon. Yeah, I can hear you. Sorry,
Excellent.
I was on mute.
No problem. Very happy that Mr. Patel with us today. He's the head international O&M MENA, Latin America and Europe for Sterling and Wilson Renewable Energy Limited, which has a presence in 29 countries globally. They are the leading EPC and operation maintenance contractor in solar. And on personal front, he has total industrial experience of 31 years. Operation and maintenance portfolio under him includes 1.2 gigawatt Noor Abu Dhabi solar power plant, which is the first of its kind mega project in the world. We are honored that you are with us, Mr. Patel, and we are eager to learn
Thank
from
you.
your experience in managing such large projects. Can you tell us? Let's start by listening to you telling us more about the best practices for selecting and implementing intelligent PV cleaning robots in solar energy projects. And you can go through the design, construction, and operation, please. Over to you, Mr. Patel.
Thank you. Thank you, Samir, and thank you, David and Ayam. I think both of them has covered a lot many topics already. To start with, like see, as we all know, these robotic cleaning systems, the first of its kind or first mega scale installation was done on this 1.2 gigawatt Noor Abu Dhabi site. So, wherein for the first time in the world, perhaps somebody has tried to install some robotic system on such a large scale. And we have a lot of learnings out of those installations. Of course, the robotic systems which are available today, they are more intelligent and quite having a lot of features nowadays. But for me, like whenever I talk about selection of any robotic system, for me the operational ease is the first thing, and as rightly suggested in previous presentations and by Yam also, that integration of the system along with the trackers, because nowadays you hardly find any project without trackers. So integration of robot with the trackers, so how good they are integrating with each other, and ultimately integrating tracker system as well as the robotic system along with the plant SCADA. That will be the first key factor for me. Second is our experience in this region. It's not only the high radiation, but it's coupled with the high temperature. And often we do have humid days. So robots being a electromechanical equipment, we always have or personally for me, I always go for the robustness of the construction, particularly of the electronic systems, because these are very delicate components which may tend to deteriorate very fast. And once those components are affected, the whole system, there are all the chances that you may have faced multiple difficulties in operating those systems. Third thing, nowadays, all these developers, or like the cost per unit is going down, and it's setting new and new world records every day. So that means you to keep your losses at minimum. Keeping soiling loss at minimum, that means your robotic system should work everyday basis. Now, so availability of the robots or the soundness of the system, that will be a most important thing. And for that, if I want to ensure the availability of the robotic system above 99%, I need to know about the consumables, the life of the individual components. Again, the effect of heat is a key factor. That's what our experience is. And particularly the life of battery, because whenever we procure the robots or any systems which are having the batteries, so storage life is highly dependent on the temperature in which it is operating. And of course, we know that temperatures are reaching up to 45 degree plus during the 4 months in summer in this region. The life of the battery, there are all the chances that if not selected a proper battery, the chance of deterioration of the system are very high. So for me, these are the key factors which I would like to check. Of course, the reputation of the supplier or reputation of the manufacturer for providing long-term service support, for providing long-term spares. That is most important, because the life of our projects are more than 25 years. And if the supplier company or the OEM doesn't have the sound background, there are all the chances that after a couple of years, we may not find that OEM in the market and we are facing issues. So, thank you. This is on short. Of course, there are some other factors which are already covered. So, I'm not going into detail for that.
Thank you very much,
Yeah.
Mr. Patel. You touch on some very important topics like the electronics and the temperature. Actually, in the Gulf countries, it might reach much more above 45. It might reach 55, 60, and and then you
Yeah,
have
true. See, because that's true. Because what happens that when your ambient temperature is 48 degree, the temperature inside your component may reach up to 50-55 degree. Yes, that's true.
brilliant. And then, what do you do? How do you put in the tender specifications? What is the maintenance life for the robotics that you are purchasing? What kind of spare parts you are usually maintaining? Can you give us a little bit more details?
Uh, yes. See,
Over to you.
as far as the tender specifications are concerned, that is more related with the developer's requirement. But for the interest of long-term benefit of the project, we usually try to make sure that the supplier who is selected can provide you the long-term services. Apart from that, see, you cannot have the OEM lifetime on the site. Maybe he is present on site initially for 6 months or 1 year, but then training, because this is the only moving part on the solar plants. So we need to have people having a different skill set than the people who are working in the PV field, because maintaining robot means you have the mechanical systems, you have the electromechanical system or electronic systems. So training on the site is very important, because every time you have any troubles and how to troubleshoot those issues without having uh, physical presence of the OEM on the site. Uh, just for example, like if the synchronization of communication between the trackers and the robots, if it is mismatch, there is a mismatch, how to attend those kind of things. If you have any issues with the battery, how to check it or how to rectify it or how to like fix it. So those kind of specialized training, that is more important as far as my practice or my opinion goes around. As far as the spares are concerned, we usually there are, of course, there are certain consumables like batteries, wheels, there are nylon parts, your brushes which require the periodic changes. So those consumables, of course, some spares has to be maintained on the sites. Apart from the PCBs, which are the master controller for the robots. So this kind of spares usually we do, but then I more insist on the training, because the site team should be able to handle it independently, even if with say remote support from the OEMs. So that's what
Brilliant.
we take. Thank you.
Thank you very much, Mr. Patel. On that note, we like to ask a follow-up question about the maintenance and training requirements for effective use of intelligent PV cleaning. Can you elaborate more on that? Over to you, Mr. Patel.
Yes. So there are a couple of things. Most of the issues with the robotic system in this region will be related with high dust level and high temperature. Now, when those both things are coupled together, it affects the electronic part. Apart from that, uh, the motors, the bearings, all the other moving components, their lifetime or their efficiency gets deteriorate to some extent. And this is our major observation, or this major learning, I'll say. The challenge is like simple as that bearing, which is a very small component, very cheap component. But then if those bearings, they do not sustain the dust or the heavy temperatures, it will tend to like the robot will draw more power from the batteries, and that will lead to overcurrent. That is again from safety point of view, it's a difficult situation. Overcurrent may lead to some sparking or some short circuit, and we know that robot is having a lot of plastic and nylon parts, so it's highly flammable. So those kind of safety aspects do may arise, I'll say. So those kind of things we need to take care. So training on checking, regular checkups of the robot, that is very important. So preventive maintenance. And nowadays, most of the robot manufacturers, I have seen that they are paying very less attention on the preventive maintenance, or hardly anything mentioned on the preventive maintenance side, because they consider that this is a more of a mechanical system, and it works well. Yes, true to some extent, but then in long term, yes, this maintenance practices needs to be take care and needs to pay attention to avoid an smooth running on the site, and also to avoid any mishaps. Thank you.
I see. Very, very interesting. And how many people you have for now that you have the robotic cleaning? How many people you have in your cleaning team supervising this operation? Over to you, Mr. Patel.
Yes, thank you. So it depends on the size of the fleet. So we have almost 1400 plus robots on our site, and we can maintain it with less than 10 people on those systems, because nowadays, even with more intelligent systems have come up, perhaps those manpower can be reduced further. But as I said, you can hardly reduce the manpower for your preventive maintenance requirement, because that is a must which we cannot reduce every time. Thank you.
Thank you very much, Mr. Patel. Our last question is regarding the return on investment and the consideration and the potential cost savings. Can you provide us with your views, maybe focus on soiling in general? Thank you very much. Over to you, Mr. Patel.
Thank you. So, there is one very interesting question. When we talk about soiling, if we say 1% soiling, does it mean that 1% loss of energy? Most of the people, they do have an idea that 1% soiling means loss of 1% energy. That's not true. And of course, that is not the topic. But the thing is, like nowadays, with all the efforts towards improvement in the generation, absolute generation, I'll not talk about the PR or anything else, but absolute generation, which gives a revenue to the developer. So keeping the soiling loss at minimum, that is very important thing. And apart from that, uh, uh, the whole issue is like if we can improve absolute generation by say 1%. uh, if somebody is from finance, they may agree with me that your IRR will increase by 2 to 3%. So the cost effectiveness in terms of increase in the generation by reducing the soiling loss, that is of course beneficial, and that benefits are in multiplication. That is not only like, if even if you can improve your generation by 0.5%, perhaps your IRR will be improved by 2-3 times. So this is the economics what I understand, and always try to follow this principle while carrying out O&M practices or asset management on any site. Thank you.
Very interesting. Can you please elaborate more about the percentage of soiling and the percentage of energy loss, absolute energy loss? Is there a correlation between them, a rule of thumb, or how do you approach that? Over to you, Mr. Patel.
Thank you. See, it's very difficult to correlate because site to site and the soiling condition, the soil condition particularly, the type of soil which is around the site, that plays a major role. But if I talk about our region, where it's mainly a dry sand, fine particles of the sand, even if with 1% soiling, your loss of energy is not that high. That is my experience. Why? Because these sand particles are not, first of all, sticky. Secondly, they are not compact. So that means they are not dense in nature. So what happens that even if there is a layer of fine sand particles, there is always a refracted energy, refracted solar energy, which will still penetrate through the surface and which will give you some generation. So, but then it's very difficult. There is no thumb rule as such. I have been involved in some researches on soiling back in India, which was been driven by a group of people from 10 different countries, including Europe. So that there also we have tried to establish a certain correlation between the soiling and the generation loss. But then place to place, it's varying a lot. Type of soil also affects a lot on this generation losses. So it's very difficult. There is no any thumb rule. But yes, in our region, this is my experience that even if with 1% your energy loss is not that much because of the nature of the soil. Thank you.
Perfect. Maybe I have to ask you these questions, but just for my own interest, out of the 1,400 robotic cleaning equipment, how many are from Sunpure? Let's
Nil.
Nil.
Zero.
We have to change
At that
that.
point
So
of time,
maybe
perhaps they were not in the market, because when
I
we
see.
have started exploring this opportunity of robotic system in 17-18, so at that time very few players were available in the market.
Okay. How about the bifacial? Are you using bifacial in your plants?
Yes, some of the plants we are using it, but those plants are having different cleaning systems.
Yes. Brilliant, brilliant. Thank you very much, Mr.
Thank
Patel,
you.
and I'm sure that we will get back to you with more questions in the
Thank you.
Q&A session. Mr. Omar,
Thank
are
you.
you with us? Mr.
Yes, very
Omar?
much.
Excellent. Thank you very much. We are very honored to have you among us, Mr. Omar. Mr. Omar is from Aqua Power, NOMAC, and he's looking after the innovation and new technologies for Aqua Power. He's focusing on the O&M side of business, and he's been with the Aqua Power since 2017. Plus, he has 22 years of experience as mechanical engineer in sectors of power, water, oil and gas, more towards the downstream on both sides of negotiation table. and he has been spearheading the deployment and implementation of automatic robotic cleaning for all Aqua Power projects. They have tested robots from China, India, Europe, and many more places. And they have developed detailed specification that, to satisfactorily deploy this technology in utility scale power projects. And it's very interesting. It's a very, very big number. They have 9,000 robots deployed so far for several gigawatt of aqua power projects, and with more than double being designed or tested. These are very huge numbers actually, and we are eager to learn about the best practices for selecting and implementing this intelligent PV cleaning robots in solar energy projects. Over to you, Mr. Omar.
Sure. So, hi everybody. Well, it's a very interesting thing because as far as the robotic cleaning is concerned and what we have seen so far, it's something that is an ever evolving technology. If you go back 5 years, the technology's just barely started, and the robots or whatever technology was available at that time, it was uh, it was good for certain reason, and it needed to be improved for a lot of other reasons. And I think if we see the very recent robotic cleaning solutions available in the market, irrespective of any supplier here, because I'm not here to endorse any supplier or something, but irrespective of any supplier, there are some really good solutions. There are some solutions which still need to improve on. Uh, but primarily, when you look into the selection process, I can only share that from project to project, it varies. You cannot just have one solution that fits all. You have to look into various factors, starting from your layout, starting from your mounting systems, sometimes what kind of a module arrangement the plant would like to have. It's I've also seen in my experience the layouts getting changed, the arrangements getting changed to accommodate robots and vice versa. So it's something that you won't go and find a technical manual and go to page number this and read and how and go ahead and select your robot. That won't happen. Let's see. I hope this happens in the future, but for now, it doesn't exist. So it is something which needs a lot of testing, a lot of experience, and only then you will be able to successfully deploy these robots.
Okay, Mr. Omar, very interesting. Let me ask you a question. Since you have 9,000 robotic cleaning devices, are you allowing the rails of the robots to move over the PV modules? And the second question, are you doing wet or dry cleaning? And the third question is, how many years of maintenance do you ask for from the robotic manufacturing? Over to you.
See, there are a few things that I would not be able to share. I hope you guys appreciate that. So
Okay.
what I can say is that when it comes to both wet and dry cleaning, we have both the solutions, because not every plant will be okay with either one of those. So you have to go back to the drawing table and look into a lot of factors, which I think uh, some of my fellow panelists have already touched base on, so I won't be talking about that. The other thing is, I hope I remember all the questions you asked.
Yeah,
The
the
I
rails.
guess you asked about the rails or the wheels. Yeah. Well, yes, it's something that you once you start running these machines on the modules, you try to see what is the best possible way forward. Again, because we are dealing with so many of them, again, I can't give you a direct answer here. This is something where we have places where one condition is there, we have projects where the other condition, that same condition is not there. So it depends from project to project, Mr. Samir. I don't think there is, again, one answer to this question.
Interesting.
And
But yeah.
sorry, what was your third question?
My third question was related to the number of years. You ask the robotic manufacturer how many years of warranty to.
Oh, that's the easy part. That's the easiest one. As many as they can provide. But they try to, the robot suppliers try to stay as low as possible. So, to be honest, it's something that is discussed at the EPC level, and this is something that needs to be looked into by the EPCs and the robot suppliers. Because keep one thing in mind: whatever the number of years the robot supplier gives, the EPCs have to match it with their commitments that they have with the project developers. So it's that. But so as far as the developers or the O&M operators are concerned, they would love to have as many as possible.
Okay, and do you work with robotic manufacturers without in-country support, or how do you do that? Over to you.
See, as I said in the beginning, this technology is still some circles within solar industry. They still believe that this technology has not yet evolved. It is still in the infancy stage. Personally, I think it is getting there. It is slightly mature. So asking about such things, it varies. And if you want to test the equipment, if you want to test the supplier, well, if you have a tested supplier, of course, everybody would have a little bit of higher degree of reliability is there with them, or whatever, your dependability on that supplier is a bit more. But if you have someone who is very new to the to this kind of market, it becomes a bit difficult. For that, I don't know if I've answered your question properly, but
No, it's okay. We'll ask you multiple questions. At the end, we will get the answers. No worries. Are you working with the solar PV module manufacturer as well when you pick the, let's say, the wet or the dry cleaning? Because sometimes it will develop scratches and that will affect the productivity and so on and so forth. Over to you, Mr. Omar.
yes, exactly, we do. I mean, as one of my fellow panelists just mentioned, I mean, just imagine, put yourself in anybody's shoes. If you are getting the robots and you are getting the modules, of course, you would like to make sure that the robots do not rub the modules enough to damage anything. So again, it's a kind of a chicken and egg story here. I will again point out to the very important fact that we, as the solar industry, let's say, globally speaking, we lack the standards, we lack technical standards in this particular domain. I hope one of my messages here on this discussion forum is to also share the same, that I hope someone somewhere is looking into it, and or we as the solar industry, we need to work towards achieving some kind of sanity with regards to these standards. Because if you don't have those standards, then anybody and everybody will be right with their own set of considerations. Everybody will say, I was right, I thought like that. So it's difficult to pinpoint to one particular thing here. We have seen, I have seen, or we have seen a varied, or my response will be very varied with regards to each project. If I can share with you, your answer is it is varied across every project.
Yeah,
because of the unprecedented nature of the technology.
definitely. And are you working also now with the bifacial products, PV modules? And what kind of cleaning combinations you're doing if you are having a bifacial?
Well, see, as far as whatever public domain information is there, the yes, of course, you can't achieve gigawatts from one plant or multiple gigawatts from one plant if you are not using biofacers these days. It's so the easy answer is yes, and but what was your second part of the question, please?
And how are you going to do the combination of cleaning for the bifacial? Are you cleaning
It
both
depends
sides?
on the it depends on the atmospheric conditions of the particular site. Again, as I said, there is no one solution that fits all. So you have to look into what kind of atmosphere exists at that site, that particular site. Sometimes it's possible that if a project is spread across 3 different sites or 5 different sites, you may require wet cleaning at one site and you may require dry cleaning at the other. It all depends on how and where geographically those sites are placed.
Very interesting. Can you tell us about the role of artificial intelligence and sensors in optimizing solar maintenance with robots, please? Over to you, Mr. Omar.
Absolutely. This is something which I would say is not even the future, that's the present of this technology. The future may look very different from now, but if you go back 5 to 10 years, I'll be very honest and all with all due respect to the robot companies on this call and not on this call. Uh, 5 years ago, if someone used the word robot for these cleaning machines, it was a bit unfair to the world of robotics because those machines were just dumb devices. Whatever sensors they had at that time, they were not geared up for what the industry required. Even today, I would say they are getting there, but still there is a long way to go. And with regards to artificial intelligence, of course, everything today we are, as humans, we are getting into this thing. I mean, we all know about Chat GPT and also that's where we are at when it's AI is concerned. But definitely, this is one thing which I would request not to. I won't be able to discuss in detail because here there are some patents involved which my company is working on. So. Yes, artificial intelligence has got a major role to play today, tomorrow, and in future with regards to how we not only clean the modules but how we operate the power plants.
Okay, very, very interesting. And um, I have to ask this question. SunPure, out of your 9,000 robotic machines, what is the share of SunPure until now?
Well, if that question is asked by Sunpure, they definitely know their share. But yes, we have a good kind of split from the suppliers. Again, as I said, it doesn't matter who provides the robotic cleaning solution. For us, it does not matter who provides it, as long as they fulfill our technical specifications, which, by the way, we have developed after uh, a continued testing phase of more than 4 to 5 years now. We ourselves have gotten into that because, again, there is no standards available. So we did all the hard work and we got all the testings done. We actually conducted the testing. We are still conducting testing. And if the question is why Sunfield, they already know the answer to this. And for others, all I can say is that anybody who has a really good solution and can prove it to us through different protocols that exist in the company, definitely, why not? I mean, anything good that supports the narrowing the margins on the LCOEs for these power plants, anything that supports that, we would love to have.
Brilliant. Thank you very much, Mr. Omar. And now we move on to David, but I want to ask some general questions to all of you and start with David. David, from your experience, what are the top 3, let's say, features in a solar PV robotic intelligent machine you must have let's say, must-have features in robots. Over to you, David. Of
Yes,
course,
thank
I'm
you
going
very
to
much.
ask all of these speakers the same questions. So, but you
Yeah.
have more time. But David is the expert, and he can answer quickly. Over to you, David.
Okay, as a lot of experts here have mentioned, I think everybody has a different view about the robotic cleaning system, but I think some basic or key requirement about the robot, if I want to say the first one, I think is reliability, because you know whatever how good your technology is, you have to maintain this good technology in a long term, and this is in relation to the long term interest from the developer, from the owner. That's the number one. Number two is your robot has to clean the module well. That means you have good cleaning efficiency or cleaning performance. This is also very important, because the reason that the developers or the EPC selecting robotic cleaning system for the plant is to clean the module. If your machine cannot, or if your robot is not able to perform the cleaning task very well, then there's no point of using this ARCS system. And if as a number three, I think is as the other topic that you mentioned is AI, or the intelligence of the robot, because only with the more intelligent technology you can optimize your cleaning performance, you can reduce the overall risk, and you can increase the design life by optimizing your cleaning operation.
Thank you. Thank you very much, David. Mr. Omar, would you like to um, answer this question as well? What are your top three must-have features?
Well, reliability, first of all,
Okay.
optimized price, and they need to be. I mean, the robots should be able to be deployed on a multitude of mounting systems, not just one or two. So, and
Very
maybe I would like to add a fourth one, which is the communication system,
communication. Okay.
the wireless
Thank you. Thank
communication
you.
system.
Thank you, Mr. Omar. Mr. Patel, over to you. What are your top three must-have features in intelligent robotic cleaning?
Uh, See, instead of that, I would like to answer it this way: that
Ah,
what should be the futuristic robot, in my view. So,
uh-huh.
for me, the futuristic robots, they should be able to sense soiling on individual rows himself and start whenever it finds that the set program the soiling level has reached to this level. It should start, go clean and come back. Second feature which I would like to have in the robots is maybe some thermal imaging or some other sensors which can detect the micro cracks or hotspots inside the modules while it is running on the robots. And third, which I think I had discussed with some of the manufacturers also, if it can have some spray system, maybe a small amount of water. So wherever it finds some bird drops or some heavy soiling, maybe a slight amount of water it will spray and then it will run over it. So this is my concept of futuristic robots.
Very intelligent robots
Thank
you
you.
want. Thank you, Mr. Patel. Thank you. Mr. Iham, what,
Yeah, I
what
think
are,
the more we can do with the linear paths of a robot, the better we can. So we're in the information age. So if we can get more analytics about the performance of our modules with robots, since we're moving on the panels and cleaning them, may as well do as much as possible electroluminescence, or like Mr. Padal said, thermal imaging, detection of certain things. That would be great. I think, generally speaking, communicating with the other overall plant infrastructure and communication, and interfacing with it, and through AI learning about how to adapt to the plant's cleaning regime. I think these things would be quite important, and maybe also the robot to be kind of self-aware of its own condition towards a replacement of parts slash wear and tear situation.
Very smart. You need a robot to be self-aware as well. Thank you very much, Ayam. This was like a change in gear session. We'll come back to Mr. David. Mr. David, he has a PhD degree from the University of Sydney in Australia, with a 14 years combined experience in power industry, and he has been involved in the deployment of various products from more than 6 gigawatt solar projects. He is the Chief Technology Officer at SunPure Technology and in charge of the product development, engineering, and project delivery. I'm sure that all of these wish lists our practitioners just told us will be valuable to your R&D in the future. Mr.
Definitely.
David, can you tell us a little bit about the role of artificial intelligence and sensors in optimizing solar maintenance with robots, please? Over to you, David.
Yeah, as I mentioned just now, I think in another way I want to answer is what I think the robotic cleaning should do in terms of AI. First, I think it need to determine when to perform the cleaning task. At the moment, normally the cleaning was done at a regular basis, like for each fixed time, the robot is perform the cleaning task. But this might not be the most economic way because, for example, even in Middle East, in the winter time, you may not need your robot to perform like 1 day cleaning. Maybe you can do the cleaning once every 2 or 3 days, or even once every week. How to determine this? So this must be through the AI, and this is also the technology that we are developing, towards. And second is, as Mr. Patel just also mentioned, I think how to predict the performance or the safety issue of the robot through different factors. Because we all run the robot like every day or in a regular basis, but whether any robot need to be maintained, need to do the maintenance, or need to do some corrective maintenance or preventive maintenance, we don't know. We just do this maintenance based on our schedule. But in the project, each robot has different status, and also each robot runs different lengths over a period. So one robot may be, the condition of one robot may be quite different from the other. So how to predict it? This has to be through the AI. If you can predict it very precisely, you will save a lot of O&M cost. So these are the things I think the AI can do. Of course, with AI, you can also communicate with other parties like the trackers, like the weathers, more precisely to determine the risk mitigation, whether you have to stop the operation of the robot because of some weather issues. And this one we also can do. A lot of robots can also do, but these are based on the current information. Whether you can do the data analysis to predict that this may happen in a short time level, then you do the preventive operation. So this is another task that AI can do. So these are just some examples I can think of at the moment. But of course, I believe with AI, a lot of things can be done to improve the performance of the robot and also to reduce the overall cost. Because you not only need to look at the capex, but also OPEX is also very important. For a typical robotic cleaning system, the OPEX cost is much higher than the capex. So once you can reduce this, then you reduce the overall cost a lot.
Very, very, very interesting points, and thank you very much, David, for your insight. Allow us to ask you one more question, please, before going to the Q&A session. What are the best practices for selecting and implementing intelligent PV cleaning robots in the solar energy projects? Over to you, David.
Yeah. Honestly, because I'm on the other side of the table, because we are being selected by developers or the EPCs. But in my point of view, of course, as I mentioned, the decision makers should, on the commercial side, they should consider both capex and opex. So the overall cost is the one that they should refer to. And secondly, I think, as Mr. Omar mentioned, this ARCS system need to integrate into the PV plant, need to interact with like the trackers and the modules. So when selecting make a decision about the robotic cleaning systems, you have to consider whether this robotic cleaning is compatible with the trackers, with the modules, and whether this is the best pair. Because I think many robotic cleaning vendors are compatible with multiple trackers or multiple modules, but there might be some best pair. So this is something that I think this will consider.
Thank you very much, David. I just want to ask you one more question, just personally to know, is everything that you're doing is run by a battery without wires? And then is it all dry cleaning or you have wet cleaning? Over to you, David.
Yeah. So the target of our company is to provide our solutions for various scenarios. Of course, for Middle East region, I believe the dry cleaning is the best solution. So for this region, we provide our full automatic cleaning system with dry cleaning type of technology. But of course, we also have our other technology, including the wet cleaning. And this might be used in some other regions where the dust is not that severe, where there might be some very sticky dust like the bird drop. So we also have some other solutions like the wet cleaning.
Okay. And last question, promise. What about the bifacial? What is the solution for bifacial?
Yeah, honestly, the robotic cleaning currently, I think all the technologies only clean the front side. So they do not do the cleaning for the back side.
Okay. Thank you very much, David. And now over to you, Chaksi, with the Q&A. Do we have questions from the audience?
Our speakers, that was a very insightful session for sure. I'll be just screening some questions and the speakers can take up those.
Question: will the robotic cleaning be effective in mountainous country? What are the challenges? I think this is David, maybe.
Yeah.
David? Yeah.
Yeah. Actually, in China, there's also a lot of sites located in the mountain. We have also deployed our projects in the hilly areas. If I think about the challenges, I think the first will be because of the irregular layout or in all the terrain. The number of robots that for a certain megawatt will be increased. That means normally the overall system cost will be higher than Middle East because in mountain areas maybe one robot is only cover like a few hundred meters. So that's one challenge, I think. Second is with the mountain area, the terrain will be not flat, and this will increase the difficulty of robot passing through different roads. But still, I think this can be solved by a lot of solutions. Like, for example, we do have our semi-automatic robot where a certain amount of human labor need to be used to assist the robot operation, and by doing that, we can ensure one robot to cover a lot of areas to reduce the system cost, and we also can do some the construction modification so that we can ensure even along one row the terrain is not good. It's like a lot of slope. But when the robot is jumping from one row to another row, there's not much slope, so that the robot is easily to pass through different rows. So still, it is still doable. To simple answer the question.
Thank you very much, Chaksi. Do we have another question, please? How EPCs are evaluating the robots while committing the soiling loss guarantee to developers? Would like to know the key factor for selecting the robot and also challenges facing. Okay, we have our esteemed EPCs, Mr. Patel, Mr. Omar. Would you like to answer that? Mr. Ayham, who would like to answer that?
I think
Mr. Patel?
may be better answered by Mr. Patel.
Yeah, Mr. Omar, go ahead.
I said it better. Maybe I think it is better that Mr. Patel takes this question from an EPC perspective.
No, it's selection as such. We do have a very limited choice as of now because your wish list may be very high, and particularly EPC contractor has a limitation because he has to fulfill the wishes of developer, and at the same time he has to manage or he has to ensure that all those deliverables are been received from the supplier, from the OEM. So EPC is always in a challenging situation because initial stages there may be commitments from the OEM which may not later fulfill or may not convert into reality. So first of all, of course, the soiling loss below 1%, that is nowadays it's like standard practice, I can say. It's not a wish list or something. It's a standard practice, soiling less than 1%, because none of the solar projects can survive in today's era with such a lower LCOE and all. So that is for sure. So in that case, the reliability and the image of the or the service guarantee or warranties, these are the major factor which we usually take into account. But yes, IHAM being from developer side, I think he can put more light on this aspect. Thank you.
Okay, thank you, Mr. Patel. Mr. Omar, you would like to add something else, or Mr. Ayham, you like to add something else, or we move to the other questions?
No, well, I think just maybe to add a little bit to it, it's quite important for us to vet the solution from a cleaning efficiency point of view, from all the bridges, the design of the bridge, and how it integrates to the tracker, its effectiveness. I think, when we're looking at EPC and developer, there has to be some sort of collaboration when looking into this robotic cleaning solution, because at the end of the day, EPC is in there for a period of time, and then developer takes over, or another operator. We don't, it depends on the project, but the idea is the plant has to live with the solution for the 25, 30 years, whatever it is, lifetime. So I think the kind of the supply agreement and the maintenance agreement and the guarantees that the robotic cleaning manufacturer passes on to the developer, which is the end user, are quite important. And negotiating those is critical, I think, especially with spare parts, pricing, kind of short-term or long-term service agreements. So I would think those are the key factors to consider.
Perfect. Thank you, Ayhan, very much. And we go over to Shakshi again. Shakshi, do you have another question? Thank you. Mr. Omar, this is for you specifically. Can you discuss an example of one of your plants having bifacial and how you decide to clean it? Over to you, Mr. Omar.
No, I can't. No. See, it's doesn't matter if it is bifacial or not, but because it depends. As I said, cleaning selection of cleaning process. First of all, you look at the atmospheric conditions. You need to decide if it is wet or dry. You move on from that point onwards. But irrespective of the fact it is wet or dry, and the fact if it is being provided by robots, fully automated, semi-automated, that all depends on a number of factors which you have to consider. Allow me please not to diverge into any real time from the plants, but what I can tell you is that you need to take a start from what I just mentioned, and maybe from that point onwards, it's a little bit of an iterative process to understand with the suppliers of different robots or trackers, if there are trackers, and the suppliers, and then you need to come up with a cohesive arrangement which works. If you have something from your past, or you have a precedent available, that would be an easier thing to move on. But if you don't, then I think I recommend do some tests in order to verify if the solution is going to work.
Thank you very much, Mr. Omar, and we go back to you. Shakshi. Do you have another question for us? Brilliant. Can the battery of a robotic cleaning system be charged from solar panels? What will be the design criteria if it can be done? I think this belongs to David. David, over to you, please. SunPure. Yes.
Yeah.
Where are you?
Yeah.
Yes,
so
yes.
the answer to the first question is yes. So the battery can be charged by solar panels. So normally, I think there are two technologies, although one is normally used. So one of them is the robotic cleaning system will provide a dedicated solar panels to charge the battery, and of course we can also use the string power to charge the battery, although it's not widely used. So this is the answer for the first question. For the second question, so there are a lot of factors to be considered for the design of not only the solar panel to charge the battery, but also the battery itself. So what we need to consider is first the environment, including the temperature, of course, which is a very important factor, and also the irradiation map of that particular site, and also the degradation over the edges. So these are all the factors we need to consider. So the target or the purpose of the design is to ensure, the battery is able to perform at the end of its design life. For example, if your design design life of your battery is 5 years, then at the end of the 5th year, your battery need to charge to power the robot to do the full cleaning. So that's a design principle.
Thank you very much, David. Another question. What are the special precautions to be taken while designing the plant for robotic cleaning proposals? I think we start with David, and then we may be be asking our APCs, our esteemed APCs. David, would you like to answer this question?
Well, I think basically this should be the question for EPCs because normally
Okay.
EPC design the plant. But just one suggestion I want to highlight is we do need to consider the gap, the north to south gap between adjacent tracker roads. If it's too short, it's definitely it's not good. If it's too long, of course, it's not good. It cannot meet the capacity. That's only my point. Yes.
Thank you very much, David, and always good to know what Sunpure position on this topic. Mr. Patel, would you like to provide some insight?
Sir, you're on mute.
Sorry, due to some connection issue, I could not see the question. Can you repeat the questions, please?
Shakshi, can you put up the question again, please?
Sakshi?
Yes. Can you see the question? Yeah.
The plant for robotic
What are the
cleaning
special
support.
precautions to be taken while designing the PV plant for robotic installations?
Well, the special precautions, or I'll say it's not a special precaution, it's a routine practice nowadays because you have to decide your capex, omex, opex, all those things, and based on that, you have to design how much undulations are allowed on the site so that your robotic system can perform better. Secondly, what is the length of the roads? Third is like you want to have fully automatic, semi-automatic, what kind of robots you do have. So it's all depends on your budget ultimately and the ultimate result or soiling which is targeted out of it. That's what I can say.
Thank you, Mr.
Thank you.
Patel. Mr. Omar and Mr. Aham, do you have any further comments? I think the special precautions maybe are from the point of view of where to install the robotic the docking station, how much extra weight that you want to put on the supporting structure. How do you sense if there is wind or no wind? Maybe these are all special cases that must be taken into consideration, in my humble view, of course.
Correct.
Yeah.
Yeah.
I'd add also probably the ambient temperature conditions because that affects your battery life, and you don't want to go into deep discharge. So sizing the battery depending how long you want to go with the rows is quite critical. As a condition.
Brilliant. Thank you, Ayhan, very much. Shakshi, do you have more questions for us? Or we are already...
Yeah, we're almost done. We're through with the questions for today. And that was a really exciting session for sure. Thank you, audience and panelists. With this, we have come to the end of our virtual event. Very special thanks to you, Mr. Samer, for superbly managing the session as usual. Also, a big shout out to our attendees for extending their time and support. And not to forget our partners, Sunpure, for extending their immense support to organize this event. We promise to be back with more exciting sessions soon. The floor is now open for networking. Thank you so much, everyone. Thank you. Bye-bye.
Thanks. Bye-bye.
Thank you, everyone.
Thank you.
Thank you.
Thank
Bye-bye.
you.
Bye-bye.
Bye.